Okay, welcome guys to my YouTube channel. In today's video, we will see uh, what are the steps for preparing RTU file configuration using IEC61850. The RTU type we are going to be using is ABB RTU 560. We will be using the software RTU till 12.4 to prepare RTU file and export ICD file, and we will see how to prepare network tree, hardware tree, all those stuff. The version we are going to be using is 12.4. In addition to that, we are going to be using other software, which is PCM600, in order to prepare ICD file. Later, we will see how to do that. We will start by initializing our initialize the project, and we will start by filling the initial data, which is it was like just as documentation. First, we will start with like a project name, then engineer name. These are data are going to be used for the documentation only, and company name and department and such things. Uh, Here we will see the number that are used to be for the naming. For instance, we are going to use like a 50 number. These are going to be divided between the substation name and voltage level and the bay name. As we know that the hierarchy of the naming in the RTU will start like start with substation, voltage level, and then bay level. For instance, we will give like the substation name is 10 letters or 10 digits. A voltage level also are going to give it like 10, and the bay name we are going to give it like 10. We click next, then we start by the network tree. We start by adding. We start like RTU 560. We select it. Just give it a name. RTU 560. Then we will start adding like the protocol, the host protocol, which is going to be like IEC104. We will add like the sub activity, which is going to be like IEC61850. We will start by adding the control system to the IEC104. As we will add like a IED to the protocol IEC61850. This is the name of the control center or the system at the control center. For instance, like LDC, and then the system at LDC, we name it all. It depends on the system that we are going to use. For instance, we use like Siemens system. Normally we use two link to the LDC, so we are going to add another link for IE704. This is the second link for the control center. Give it like a LDC2 or LDC1, just the name. We are going to use like to add to control system to this protocol, and we are going to give it a name also. Yes, we are going to use an array system. IED. This is IED name. It shouldn't be like this. So just we are going to change the name. This is the name of IED. For instance, we are going to use it like to control a transformer or a line. Give it just a name. It shouldn't be like this IEC61850. We should give it a name like have a meaning. This is the name of the bay, AA1, A1 transformer 5. And just we are going to name the protocol here. IEC61850 link. This is the most here. The details here are very important because the name we are going to use it here. We will need it later in the PCM 600. So we need to be very specific here. The same name we are going to use it here. It will be needed in the PCM 600. So let's name it like client. Remember, we are going to use the same name in the RTU tail. Is going to be used the same name in PCM 600. So in this specifically, the name in the RTU tail and the name in the PCM 600 should be typical. Client 10. We are going to use it later. Access point. Let's use S1. We prepare the RTU tail. Sorry, the network tree. For the time being safe. We will define the RTU hardware that the type of the rack we are going to use, which is SFR. We select that. We will start adding the details of the rack, power supply, and we are going to use like CMR02. In this port, we will add like CMR02. CMR02 has been added. Here we'll see the details of CMR02, which has two Ethernet port. We will start a link with the Ethernet port. A1, Ethernet port 1. We link it like the LDC1. When we add that, LTC1 is going to be added to the both port. So we delete it from one of the port and we let the other one. The Ethernet, we'll try to add the IEC link. So as we see, the link here is added also to Ethernet 1, Ethernet port 1. So here the Ethernet port 1 is working for two sides. Is receiving data from IEC61850 protocol, which I mean from the IEDs, and send the data to the LDC through IEC104. So here the port is working for the two side. It's working for the two side, bringing that data from IED device and sending data to the uh, control center through using IEC104 protocol. As I had mentioned, we are going to use two links for the LDC and one link for IEC61850. So one port will be working for the both 104 and IEC61, and the other port is going to be working for IEC104 only. Here we'll add the other link to the LDC IEC104. As I mentioned, we'll be adding for both. So we delete it. Okay. Then finally we have like IEC104 in Ethernet port 2 and IEC104 in Ethernet port 1, in addition to IEC61850 in Ethernet port 1. We will start the details, adding the details, IP address of each one. For instance, we'll start by using like 10 or 19. Just you need to enter the IP address that you are going to use. The second IP address, for example. So I have here like the switch that I'm using is using the default IP addresses 192.168. These are the default IP address come with the switch. You can use it, or you can use the IP address that you are going to use actually. So let us use the actual IP address that we will be using. Then the second port will give it like an IP address. So we should notice that since IEC104 link 1 and IEC61850 are working in the same port, which means that the IP address that IED is going to take should be in the same network in order to be able to communicate. So we are going to add like the master IP address. Let's say it's master IP address. Master IP address is normally the TCI, telecontrol center interface. Second IP address is going to be used like when you are using your when you are using your laptop in order to diagnose RTU. We are going to communicate with it as like master. Sometimes we need to do so. For the second link, we are going to use like a master IP address. As I mentioned, it is like the TCI. Here is an information object address. Normally we have structured and non-structured. It comes default by non-structured, so we are going to divide it to 3 bytes in order to be structured. We do the same here. We divide it to 3 bytes, 4 bit. It is going to be divided to 3 bytes in order to be structured. It is easier for us. There is a point to be mentioned in the older rack, CSR, communication sub rack, which is normally when we want to add like a binary input, binary output card, they are not going to be used in the same rack. Okay. As I mentioned that we in previous uh, rack, binary input and binary output should be in separate rack, but here we will be able to use binary input and binary output in order to communication along with the communication card like CMR in the same rack by using the SPB. Selecting the SPB, which will add an input output port to the rack. So by this feature, we'll be able to use binary input and binary output in order along with CMR in the same rack. Okay. Okay. As you can see, you see in the hardware tree, as we stand on the IED, there is no IP address. Later we will see the IP address of IED, how we can import it. Uh, so we are going to add like another IED. We just name it like give it a name. For instance, AA1, A1, TR6, Transformer 6 or whatever. Just give it a name. Another IED with another name. We go to the network tree. As we see in the signal tree, there is no signal yet. Later on, when we import import the exit, we will see all the signals will be added. For the time being, we are not going to add any signal. Yes, we are going to save. Okay, create new file. Okay. So in order to make a whole project, there is a file will be prepared in from RTU, and there is a file will be prepared from PCM600. So let us make a file for each one in order to be able to complete a whole project. For instance, RTU file, another file for the PCM file, PCM file. Okay. From this file, we are going to complete the whole project. First of all, we start like a RTU file. Save. We go to extract, ICD export, choose ICD, the track. We are going to put it in the RTU file. ICD file, save, export. RTU file is successfully, or ICD file is successfully exported. Okay.